Thank you very much for being with us remotely. We start now the session, and we are happy to have you as a first presenter of this session. Kanmani Budi, for the people here in the room. Kanmani Budi is from BMS College of Engineering in Bengaluru. Some years ago, I was at your university with a conference. And she is a professor, and her research interests are especially in the field of signal processing and signal processing education, and also engineering education in general. I'm especially happy to see from the topic of your speech that you made the EGIP certification program, and so we are keen to hear your experiences with pedagogic qualification of your colleagues. So the floor, or better, the screen is yours.
Yes, sir. Thank you so much. I'm glad to be here, and thank you for the opportunity. So I'm glad to have Dr. Michael Oyer as the session chair, and I proceed with my presentation. And it was interesting to see that it's associated with the CEO of the CTI. And just going through a lot of academic activities happening through this platform, and surprised to see the number of conferences in engineering education happening. I'm sure all of us who are attending this session must have been associated with one or more of these series of conferences in engineering education. And the work that I'm going to present is based on the improvements in pedagogy after having attended the International Engineering Educator Certification Program. The sequence of presentation will be, I go through the course, the content, and how it was delivered, and a small introduction on the engineering education in India, our college, the BMS College of Engineering, and the specific course, how it evolved, the course on signals and systems analog, and the changes that were introduced in the teaching learning process, some reflections and some dreams. Now, coming to the certification program, it's a program, a 6-month course that is designed and delivered and jointly delivered by the IUCE Foundation, and it has recognition by the Egypt, and with the executive directors being Dr. Krishna Vedula and Dr. Veena Kumar. The course, incidentally, this course was offered first on our college campus in 2015, and it was a physical mode, face-to-face mode. And eventually, over the years now, the course is completely online, and it's offered through the Canvas platform with the 1 lecture per week and an office hour. And there is a need to submit assignments and engage in active discussion. Well-defined calendar, the speaker, the topic, everything is shared in advance. And the course is offered through 5 modules. And as participants, for us, there was a need to submit submit a portfolio and make a capstone presentation. Now here I take present some details of the project that capstone presentation that I had made during at the end of the course, and some learning that happened through the course. The first module focused on teaching learning, and here we got introduced and we came to know that there are two the ARCS model, the Lohmann's 2D model, and then the brain-based learning. And in particular, the fact that the knowledge is always assimilated in small chunks, And we also engaged in activity where we were asked to map our location in that model where we lie in the intellectual excitement component as well as the interpersonal rapport. These are the two essential components in the teaching process. And the second module focused on course design and delivery. And here there was a need to engage in other methods. We were asked to implement the flipped classroom, and we also had to define the outcomes and submit the report. There was the emphasis on active engagement in the class and implement an activity and then share the learning after having implemented an activity in class. There was the next module took us through the use of technology, and we were introduced to various tools, and we had to implement and share our experience. And of course, the last module had significant emphasis on the assessment tools, the need to design and ensure that we address the intended outcomes. We also had to take student feedback to help improve our teaching methods. And towards the end of the course, we had to take the feedback in the beginning and in between and towards the end. Some summary of the feedback that was taken towards the end. The students did have some positive comments about the teaching. However, they also have had raised some concerns, and they said there is a need to go slow and have additional examples for certain topics where they found it essential. The 6-month course finally culminated in the capstone presentation. And incidentally, this presentation I made on the 25th of December 2023. And the last slide of my presentation included this dream, concluded with the dream that I had an opportunity to present the pedagogy on experiential learning during the Learning Ideas Conference 23. And I expressed the hope that will it be possible to share the experience of going through this certification course in the Learning Ideas Conference. It was a dream that was presented and expressed during the capstone presentation. And it so happened that on the 12th of Jan, received a mail calling for proposals in this Learning Ideas Conference in the special session of the Egypt. And it's like a dream come true. And I got reminded of the saying, if wishes were horses, beggars can dream. And that is here today. This session, this presentation for me is like a dream. It's a dream come true. So now I'm walking through the presentation, the benefits. So this is what happened previous semester during while taking the course. And now I present how I applied and how I tried to improve the pedagogy in the course that I handled this following semester. And before that, I thought a brief introduction on the engineering education in India. 2014, India became a signatory, was recognized as a signatory of the Washington Accord, and the National Board of Accreditation represents India. And in India, we have two types of institutions. Institutions which are affiliated to a university, and they deliver a curriculum. They prepare the students for the exams that is designed by the affiliated university. The other group of institutions are the autonomous institutions. They are known as the Tier 1 institutions. And the Tier 1 institutions have academic autonomy, and hence they have the freedom to frame the curriculum. They also conduct exams. And students who graduate from programs which are accredited by the National Board of Accreditation. Only students graduating from the Tier 1 institutions are recognized by the Washington Accord as on date. The graduate attributes defined by the Washington Accord are aligned with the program outcomes defined by NBA, and hence the entire engineering education in India is focused on trying to develop the outcomes defined by NBA. And these outcomes are identical for both types of institutions, both the Tier 1 and the Tier 2 institutions. So the education is focused on developing these 12 outcomes in our students who are going to graduate from the program. Coming to the our college, the BMS College of Engineering, Bangalore. It's established in 1946 with the vision to augment the human resource in quality in technical education and training. And the college, to put in a few statements, it started with a social commitment to contribute to the technical manpower. They have a very well established strategic plan and institute policies, and this is reflected by the fact that there is a huge demand for admission, much more than the available capacity of the college. And the academic quality of the programs in the institution is reflected by the fact that all eligible programs are accredited by NBA. Our alumni are spread across various countries, and they serve in various domains. The institutional policies is reflected by the fact that the employee retention is more than 95%. So it's a dream for all to pursue a professional career in BMS College of Engineering, and a dream for students to acquire their degree from our institution. We also have a number of faculty who are recognized evaluators by NBA. And here I would like to add that during the COVID period, our institution, the policy of the institution ensured that all of us did receive the complete salary, and no, all of us continued to serve the institution. So this speaks volumes of the priorities of our institution. And coming to the type of institution, our institution was a Tier 2 institution until 2008. And subsequently, and we were affiliated to the Visvesvaraya Technological University. And from 2008 onwards, we are recognized as a Tier 1 institution, and hence we have the responsibility to design our curriculum and deliver and also plan our assessments. This responsibility brought in certain initiatives on campus, and the first activity was to ensure that we frame the curriculum, and we try to integrate the theory, tutorial, and the laboratory component into one. And one component we tried to ensure was to enhance the laboratory experience, and of course try to improve the pedagogy. And we realized the need that we have to introduce alternate assessments and move away from the conventional closed book exams, or have additional assessments to test, so that we're able to test the skills that are defined by the program outcomes defined by NBA. Several departments in our college offering undergraduate, postgraduate, and the PhD programs, and I am serving in the Department of Electronics and Telecommunication Engineering, which the department was established in 1986, and we have a vision. And as we can see, the mission, it starts with the need to design a curriculum that develops holistic students, and and of course all other essential skills. Now here I share my personal journey of teaching signal processing, which commenced in 2006, but I'm associated with BMS since 1995. How the course evolved, the course that the signal processing course evolved, and how the pedagogy improved in view of having taken the international certification program. So coming to the signal processing, since we are from the electronics and telecommunication engineering program, signal processing concepts become one of the core essential concepts in our domain. And prior to 2008, since we were affiliated, we had to offer the curriculum that was designed by the university. In this model, we had two courses. The first course was Signals and Systems, and it was followed, the second course was Digital Signal Processing. This first course, on Signals and Systems, had both concepts related to continuous time systems as well as discrete time systems. And hence we had the impulse response, the convolution sum, the convolution integral. We had the Fourier series for continuous time as well as discrete time system. We had the Fourier transform for continuous time and discrete time system. We had Laplace transform, Z transform. And there was no design experience in this course. There was no laboratory experience. And it was more like a mathematics course, a series of concepts and an aim to obtain the desired parameter. So this was not a course appreciated by many, and despite sincere efforts in teaching, the students did not really comprehend the concepts of this course. The second course, the digital signal processing course, was focused only on digital systems and digital signals, and this also had a laboratory experience. And specifically, there was a design component, design of digital filters. So comparing the two courses in signal processing, students and faculty both preferred the second course because of the course content and the learning experience of the course. In 2008, when we got the academic autonomy, the first effort was to address the problem that we had in these two courses of signals and in signal processing. As a first step, since we have a course on digital signals processing, we divided into two distinct components. The initial course we planned on signals and systems analog, and the second course, signals and system digital. So the academic autonomy gave us the freedom, the responsibility to frame the syllabus, and then we tried to address the issues we were facing in the signal processing stream. And the added advantage of dividing into signals and systems analog and signals and systems digital was that we were able to offer as one of the internal assessments the IEEE SSA, Signals and Systems Concepts Inventory, as one of the internal assessments. So this made it possible. This division made it possible, and this is what we could achieve. In 2008, we came out with this method. And incidentally, at the same time, there was the conference by the IEEE Signal Processing Society in 2009, and we presented that we could explore into having the first course on signals and systems analog, the continuous time signal processing. And we already have the second course on digital signal processing. And I must share the experience because it's unique, and it was the first time we were introducing this, and we were introducing the signals and systems concept inventory. And it so happened that in the conference had the opportunity to meet both Professor John Buck and Kathleen Bays in person. Those moments still remain in mind. And in the same conference, another unique experience, unforgettable experience, was the opportunity to meet Professor Simon Haken. The entire signal processing development, I think in my career, I have referred to the textbooks by Professor Simon Haken, and hence it was beyond, I cannot describe the joy and the pleasure of meeting Professor Simon Haken during the conference. A small diversion, but then now getting back to the work. Here, I'm going to present the benefits of the first course, the Signals and Systems Analog. It's a core course in the third semester. After this international certification program, what improvements happened in the pedagogy? So it's a third semester course, and we had 54 students registered for the course, and it was delivered through lectures, a tutorial, and laboratory sessions. And the benefits, after attending the course, I put it in few 9 major heads: uh, defining course outcomes, the pre-test, the recording student attendance, and the what are the types of activities we introduced in the course, and of course the assessment of the theory and the laboratory component. We also introduced the self-evaluation, and we'll also see how the program outcomes are addressed by the course. Now, coming to course outcomes, it's since 2014, India became the member of the Washington Accord. We have been defining the course outcomes and mapping it to the program outcomes. And there is one model or one accepted model wherein the course outcomes are aligned to the course content. So if I have 5 topics in the course, there are 5 course outcomes written, and they're aligned to different topics. And later on, there is an attempt to define competency indicators, which are aligned to the program outcomes, and of course, there are also performance indicators. There's another model where we define the course outcomes, which are not defined aligned to the course content, but they're aligned to the intended program outcomes. And each of these course outcomes are then justified by suitable assessments. And of course, we have a mapping strength, which is dependent on the weight of the assessment. This is the method we were following. And since there were 2 models of defining course outcomes, sometimes there was an element of confusion. And attending the IIEECP program, where we had experts share the taxonomy levels, and they took us through the process of defining the course outcomes, we realized that we could continue with our method wherein we define course outcomes aligned to the intended program outcomes and not aligned to the course content. So accordingly, the course outcomes for the course, we have a clear alignment to the program outcomes. So we have the first one on application of knowledge. Second one involves analyze and conclude, and then the design experience. And we also have a seminar component, and then we have the laboratory experience. And now if possible, my apologies, I had shared the opinion poll questions just yesterday. So in case it's ready, I would like to have the poll launched and the results of the poll, if possible. Because as a faculty, often I walk into the class and then I start solving a problem or delivering the intended course content. And then I realize that the students are not having the necessary prerequisite, and then I engage in delivering the prerequisite. And because of this component, the lesson plan gets affected. How many of us have gone through a similar experience? Okay, I think I'll continue. Through the IIEECP course insisted on taking a pre-test and conducting a pre-test. So listed all the essential concepts of the course, and then we conducted a test. And these are the various topics on which I did. And then I realized that my students have relatively less knowledge in the domain of complex exponential and Euler's identity. And hence, based on this performance, I dedicated one complete lecture to address the prerequisites. And this one lecture took brought in a lot of benefit, because eventually I was able to address the concepts of the course much better. So this small task resulted in tremendous improvement in all subsequent lectures. Attendance, of course, is essential to take attendance, and then came out with the policy that students can sit in any place they like, but they shall sit in the same place throughout the semester. And the attendance sheet is prepared according to their choice. And then once we have it, the process of taking the capturing student attendance becomes extremely simple, because all that I need to see is the where I have less than 4 students, and then pick up. So that was one component. Uh, and the office hour was something that the course insisted. They said that we should have a clear, well-defined office hour, so that the students can approach the faculty and have any doubts addressed. And accordingly designed this office hour weekly 7 to 8 p.m. I made it online through the GoToMeeting platform. And since only interested students who have some specific doubts or some points to be discussed, these online sessions known as the office hour, we had around 20% of the students attend and benefit from the interactions. The significant emphasis was on ensuring that we have activity based delivery. And some of the activities that we have introduced was uh, whenever I had a new tutorial session with the problem to be solved, a numerical example to be solved with a series of steps. The students solve it, and then one by one the student comes to the board and puts in one additional step. This keeps everyone engaged. Everyone attempts to solve the problem, and then they come to the board and do it. This was an activity which kept all the students solve the example that is being discussed. Of course, an opinion poll, whenever questions had had binary answers. Is it stable, unstable? Is it low pass or high pass? Such type of questions always had the raise of hands. And incidentally, there was honesty when they raised the hands, and it helped some to have a measure, quick feedback on the percentage of students who are grasping the concept. And in the previous last year, I'd shared the need for adopting experiential learning, and this semester is we implemented the experiential learning, and wherein we design the experiment. So experiment, the students go through conduct the experiment, uh, and then they make a conclusion based on the experiment conducted. And once they have the conclusion, then the usual process of making the formal statement, the proof, and numerical examples followed. The concepts which were addressed through this experiential learning in the course were convolution, step response, Fourier series, Fourier frequency response, and of course the cutoff frequency of system. In order to maintain attentivity and active student engagement, the STAR concept was being practiced. Here, whenever a challenging question is made, and if one student answers the question, he or she is rewarded with a star, and the stars eventually get translated to 1 or 2 marks. There's a maximum of additional 2 marks through this component. And last semester, we had 6 students who secured additional 1 mark, and 2 students got an additional 2 marks. So, but this concept, this method of instant reward to challenging questions keeps the class active, and there is a desire by all students to earn the star. Maybe once in a week or once in 2 weeks, whenever I had the tutorial sessions, to break the monotony and to put in some element of break, started the process of narrating short motivational stories, 1 minute maximum. And these stories were actual stories of our alumni who are placed in as entrepreneurs or with name, with the organization, so that our students can connect with them if required. When an when a successful story was being shared, I shared the name and organization. But in case I was sharing and not an unsuccessful example, I did not reveal the name of the alumni. The idea was, in addition to technical knowledge, the students also need to have a successful career, and these stories, short stories, I mean, without affecting the regular lesson plan, I found it effective. And then we get back to the class, the academic activities as planned. Moving further to the assessment component, of course, as defined, as the course outcomes were well defined, we had assessments to aligned, designed to help measure the defined course outcome. We also had a seminar activity wherein the students in groups of as team members, they presented an application of a signal processing concept for society. This is a course, the first course, and now we also wanted to ensure some continuity, and hence the team, with the idea that they have presented in the first course, shall now implement. I'm handling them for the second course, the Signals and System Digital. In this course, they will be implementing the idea that they presented in the previous course. So we want to ensure there is also an element of continuity through the course outcomes wherever possible. And one of the assessments of the internal assessment of the course included the IEEE SSCI. And we had a series of quiz in the course, and one of the quiz was the SSCI. The student performance in this test is as shown. We have the lot of students securing, the peak is around 18, and this is a test of 25 questions with 1 hour, all objective type, that tests the students on the fundamental concepts of continuous time signal processing. And hence there is scope for improvement, and there is a need to further improve the pedagogy. The same performance concept wise, when it was analyzed, we find that in spite of all these efforts in teaching, the relative knowledge in the time domain is much better than the knowledge that the students have gained in the Fourier transform or in the frequency response. So there is a need to address this gap as well. Coming to the laboratory component, we took them through. The students do not have any prior knowledge of Python, and the lab sessions were so planned that without any prior knowledge, we start with simple examples, and eventually every lab session we built 1 or 2 functions towards the end of this course. We had a small implementation of the analog signal processing toolbox. So given any transfer function, the students can analyze the system. Given any requirement, they can also design the required filter. This is what we developed through the lab sessions. And we also had the another tool, the electric circuit simulation tool. We use the Multisim, and here the students, we try to develop the ability to test the system for parameters, and also design and implement the analog system. Consciously, we decided not to use any inbuilt functions in our lab sessions, and hence we started with the mathematical equation, wrote the function for the application, and used it. And we also had an effective usage of the text editor, and hence the students finally just had a PDF of the complete lab session with the theory, the mathematical equation, the Python function, and application of the concept through numerical examples. Now, here I need to share the experience that I had yesterday in the lab. I mean, until last week, the Python programming environment was we were allowed to code. But 2 days ago, the Python programming environment has changed. We use the Google Colab, and it starts in this manner. So I always thought that AI is for the computer science the people, and I will continue in my comfort zone. But then I realized that the AI did invade our Python programming environment. So I had a small task yesterday. The students had to draw a circle, and they drew the circle, and then I was surprised that they were having it. And then I asked, how did you get it? And they have just generated using AI. Walking around in the lab, I found some students had something different, and then I asked, how did you have this different output? And they said, ma'am, the Python suggested it, and they just accepted the suggestion. So then I realized that there is we need to now probably from giving a problem to assessing. I think now there is a need for us to ensure that our assessments will test the students on they explaining what the results they have got. Coming to the laboratory component, the assessment in the lab component, we had both the small component, which was a closed book, and then we had a significant component, which was the open book. And in the open book, we had two types of questions. One which could be solved by paper and pen, and there is a set of questions which cannot be solved by paper and pen. So here I will look at the I will take the examples. So this examples here, if we see here, in this case, it's an open book exam, the lab exam, but the questions are such that I cannot solve it with, like, for example, the Gaussian pulse and integrating and then obtaining the area. Something we cannot do. They are generating the distribution of marks for a course, and also trying to, this is an example. The third example is based on trying to obtain the Fourier series representation. So they need to implement and then arrive at the result. One method that we consciously introduced was the self-evaluation. Every assessment that had, whether it was a theory or the lab component, a quiz or an internal assessment, we shared the solution on the Google Classroom. And students had to recall from memory what they had written and engage in self-evaluation of their answer script. And of course, in case the faculty, I would have evaluated it. And in case there's an exact match, or there is a difference of plus or minus one mark between my evaluation and the self-evaluation by the student, rewarded it by an additional 1 mark. So at the end, the purpose of introducing this component was the process of engaging in self-evaluation, going through the correct solution itself is a learning, and students learn. So with that in mind, this was introduced. Coming to the POs addressed by the course. Of course, the performance. This is the performance of the students in the internal assessment, the lab, and the theory, and finally the letter grade secured by the awarded for the course in both the lab and the theory component. The lot of effort have gone into the OBE process, and too much of computations get into arriving at the attainment. So we thought we'll come out with a simplified method, and we have a mapping strength classified as 3-1 based on the weightage of the assessments. And once I have the pass percentage of the course, I just multiply the mapping strength by 3 and then multiply by the pass percentage. So a 2-step process gives me the attainment, because attainment is purely towards continuous improvement. we are not getting any other accreditation doesn't happen based on the attainments, but it happens through the other student performance and other parameters. Now, coming to some reflections to understand to get the feedback. Once again, we conducted a survey at the end of the course, and out of 54 registered students, only 42 took up the survey. And some observations, the pre-test, the fact that we did the pre-test, this is appreciated by most of the students. And the attendance of students having to sit in the same place, not well received. There's a significant number of students who do not like this idea of sitting in the same place. I mean, close to 18% of them. The another component, we said we will not use inbuilt functions, and we will write the code from the mathematical equation. While 81% appreciated, there are a set of students, they say, why do we have to write the code when there is already a ready code available? It's debatable, but of course we continue with this method. The process of self-evaluation, this is appreciated by the students, and as it helped them know the right answer to the question. The lab access to the lab record, any content, is again appreciated by the students. Coming to the positive aspects of the course, there are some components they have appreciated. They said the content was evenly spread through the semester, and they have also appreciated the star concept, and it's surprising to see that they have also appreciated the real stories of senior students, and it helped them, it motivated them. Of course, there is some concern as well. They want more examples. They want the number of assessments to be reduced, and they want the faculty to be more approachable. Now, coming to the programming tool, recently I migrated to Python out of necessity, and throughout more than 15 years, I think I've been associated with MATLAB, and having migrated to Python, now I am continuing. But our students, they use both MATLAB as well as Python as they find convenient. And I was surprised to note that the MATLAB offers the interoperability feature, and wherein they are able to, one can call MATLAB from Python, and we can also call Python from MATLAB. So this feature allows one to continue in the programming environment they are comfortable with. Now, some memorable moments that have been very recently, just 2 weeks ago, this book on digital signal processing using Python is available, and it includes all concepts. It also has access to the Python codes to explore further. And presently, of course, I'm working on the analog signal processing, the first course, the analog signal processing concepts. And after having taken the course in the previous year, this Jan we had the IUCE organize its signature event, the annual conference, and that they gave away teaching supportive, the continuous support at all stages. And of course, it's my pleasure to have got the opportunity to attend this IIEECP course. And since 2015, the IUC is offering, and in BMS we have over 20 faculty who are IIEECP certified. Sincere acknowledgements to the management of our institution, and thank you.
Thank you very much for your interesting presentation. We have a little bit time, 5 minutes possibly, and there's also one of the participants ready to comment or to ask some question to you.
Okay, hi, thank you for your presentation. I'm Matti from Finland, so on the totally other side of the world. And I want to confess that I'm not a signal processing professional. However, what I find very interesting here was that how similar we are, in that sense that the tools that you used, Multisim, MATLAB, Python, these are exactly what we have here in our, or not here, but I mean everywhere. So these are the tools that we engineers use in this field. I was really surprised that we have the courses in our curriculum almost with the exact names that you have there, and
That's
and also the things that you pointed out that I personally highly value is that this multidimensional evaluation, that there was like evaluation, there was like open book exam, there was like exam without a book and a lab works. And it's also interesting to see how similar the students are, because based on your presentation, I got the impression that the things are like also in Finland, that students prefer learning by doing. And that's something that I found important also in your presentation. But the most important sentence in your presentation to me was passion to teach. Because when you have a passion to teach, it gives passion to learn to the students. So thank you very much.